Hello everyone, my name is Du, and in this presentation I will introduce you Ergo tooling system from Nine9. Ergo is the innovation tooling system for ER indexable cutter and fully compatible with the ER16 collet chuck. The presentation includes the content as below. First, where Ergo ideas come from. Second, Ergo's features. Third, user demand. We notice the narrow space inside the Swiss type lathes. The users always complain the narrow space limits the choices of the cutting tool. For example, the user wants to use the 14mm end mill, but the ER16 collet only supports maximum 10mm. So the user has no choice to use the smaller end mill and lower the cutting parameter due to the smaller tool. This limitation reduces the machine quality and the efficiency. We heard the complaints and we saw the potential, and this is the reason why we developed the Ergo tooling system. Most of the Swiss type lathes adopt the ER16 clamping system on their machines. Due to the narrow space and the limitation of ER spring collet, we see the opportunities. Our target is to replace the spring collet. Why? As you know, the disadvantage of the ER spring collet. First, tool diameter is limited. For ER16, the max tool diameter is 10mm only. Second, ER spring collet is low rigidity, and it's difficult to do some heavy cutting with the ER16. Third, there is the precision risk of the ER collet. Because tool shank and the collet quality both have the assembly tolerance. This tolerance will cause a big risk in precision. When we use the ER spring collet, there is one thing really important. You have to check and clean the collet inside and outside every time before using, and this is very time consuming. Otherwise, chips or rust will cause the big runout issue, even damage the collet or taper. This damage will reduce the product's quality. On the left side, it shows the clamping structure of the ER spring collet. When we tighten the ER spring nut, ER spring collet will compress to clamp the cutting tool. Be cautious of this uneven tightening situation. You can see on the right picture, chips, rust, and deformed collet all will cause a too tight or too loose situation. Also, spindle taper will affect the concentricity and the runout, and it is needed to check before assemble. In this slide, here is a true story from the user in Taiwan. He owns about 5 Swiss type lathes, and the main business is producing medical parts, hardware, and bicycle components. He said, there is very few indexable tools for ER16 system. He needed to rework the tool shank size down to 10mm to fit in ER16 collet, but the rigidity and the runout are very bad. He has no choice but to lower the cutting parameter. However, the surface roughness is still bad until he sees Nine9 Ergo. After the background and the user demands, now let's start to introduce the Nine9 Ergo system. What advantages can Ergo give us? I will tell you one by one. First is the monoblock design. Ergo contains 3 parts: Ergo nut, Ergo pin screw, and the Ergo holder. The Ergo holder design combines ER taper and the insert type cutter. So it is a solid collet instead of spring collet. We call this kind of design is monoblock. This design can improve tool concentricity and increase rigidity, and it is 9 patent. In this slide, we talk about the spec of the spring collet. It is defined by the DIN 6499 and the ISO 15488. From this table, the max tool diameter is 10 mm for ER16, and the runout standard is 20 micrometer. In this slide, you will know the actual Ergo taper measurement. We measure the taper runout in much more critical way. The measured length is longer than the standard request. Furthermore, the standard request, the class 2 runout is within 20 micrometer. What is impressive is that the Ergo runout is around 2 micrometer to 6 micrometer. This is much better than the standard request. ER solid collet design is the trend. Some of the tooling makers already have the solid collet design, like Iska, Kalameto, and Tangaroid, because they know solid collet has the better rigidity and the higher accuracy than spring collet. We are not the first one to use this design, but we are the first one to combine solid collet and the insert cutter in monoblock design. We make the assembly tolerance test to measure the deviation of the tool length. With the same tool, we clamp and unclamp the nuts for 10 times within 30 Nm torque value. We get maximum deviation is only 7 micrometer. The tool length is very stable and excellent repeatability. For the Ergo family, we now have these applications: NC spatrio, engraving tool, chamfer mill, power mill, and the last, eye center. If there is any further information needed, please search the Jimmo Ergo on YouTube. We have many videos on YouTube for introduction and this demonstration for you. Our webinar will end here, and thank you for your listening. See you next time.